Vehicle electrification is one of the biggest trends in the automotive industry today. The future is smarter, more connected, and greener. Customers expect more than just transportation. They want things like fast charging, extended driving, and personalized experience in a sustainable, compliant, earth-friendly vehicle. Now, how do we get there? To answer this, we have with us Mr. Shivendra Bansotra, Portfolio Development, Automotive, Siemens Digital Industries Software. He will talk on paving a smart path to an electric mobility future. Welcome, Mr. Bansotra. Platform is all yours.
Good afternoon, everyone. My name is Shivendra. I'm from Siemens Digital Industries Software based out of Gurgaon. And thanks ET Auto for hosting me into this EV Conclave 2022. I'm going to take you through a presentation on vehicle electrification, how basically we can use digitalization and pave a smart path to the future of electrical mobility. Now, what is causing the massive level of complexity today? Now, while there are many number of underlying symptoms there are three overarching trends that can explain where we are today. Now, automotive innovation is at an all-time high. OEMs, technology leaders, and startups are moving faster than ever before to develop the next innovation, next innovative product that will potentially catapult them to a leadership position. The second trend is about customer connectedness. A customer today not only want but demand to be connected every time, and they need information on real-time traffic, personalized playlists, alerts and notification from family and friends. So these are some of the requirements customer expect in the transportation experience in the vehicle. Now, additionally, on top of that, this definitely needs to be provided in a safe, secure, and reliable environment. The third one is basically the vehicle must be developed today to operate in an environment which is sustainable. So because of increasing need of regulation, both at the local and both at the global government level, are one of the examples of the pressures that automakers to develop and deliver the vehicles that are more environment and safe throughout the possible. Now, when we look into the disruptive innovation, automotive value chain is definitely changing. This is a recent study done by Deloitte investigating the expected revenue growth in different segments between 2018 to 2025 within the industry. The striking conclusion is a massive shift towards the electronic infotainment communication, which will respectively see almost about 18 to 16% growth respectively, while when we see into kind of an investment in the transmission and IC engines that are expected to decline almost by 6 to 8%. These trends are indicated of a changing automotive value chain, which are there. When we look into customer connectedness, what we mean more by that automotive, electronic, and software market will see a significant growth throughout 2028. The vehicles will be driven by electronics, software, ECUs, come up with technologies which are needed for electrification automated system within the vehicle. The third key element of the trend, which we talked about, environment sustainability, there has been enormous pressure to lower the CO2 emission in the last decade or so. The automakers have really responded with an increased investment in developing the EV. Almost all OEMs and major suppliers today have products that are targeted towards the zero emission, need of the zero emission. Now, when we look into the context of these disruptive technologies, the trend of customer connected products, sustainable energy, we see in the scope of vehicle electrification, there are definitely the challenging engineering needs which are there. On the one side, automakers need to meet customer expectation, industry regulations, product differentiation, which they are really bringing to market, unique product to the market than their competitor, and the need to basically scale the production. At the same time, they need to take care of maximizing the profitability for the organization. They need to bring the product at the level of quality which is acceptable by the consumer, continuously work toward reducing the cost of the product, cost of operation, and time to market. Now, balancing these market norms and the rapid new product introduction is an extremely challenge for the EV market players. Now, we believe that the true automotive leaders, the disruptors, will harness the complexity as a competitive challenge Now, with Siemens, we accomplished this through three key components in our strategy that provide a competitive advantages to our customer. The first one is the most comprehensive digital twin, which basically allows our customer to continuously optimize the product development, design, production, and service activity with a closed loop connection. So pretty much they are able to design in a virtual world and correlate with the real world performance. So this insight which they get from this particular virtual and real world testing really help them basically continuously improve the product, and they can build products which are connected, which are flexible to handle which is getting enabled through our digital engineering and manufacturing capabilities. Now the second key competitive advantage we are bringing to our customers is a personalized, adaptable, modern solutions which really help our customer to meet the challenges of increasing customization, personalization, and sophisticated software and controls to deliver vehicle the system in a scope, on time, and under budget. And the third key most important aspect is basically a flexible open ecosystem, and that has been the Siemens open digital strategy, which allows automakers to align their processes and expand their product and service offering while basically contributing to the entire value chain. Now, when we look into the deeper look at the wide-ranging and deep technological solution for the vehicle electrification, Siemens provides the electrical and electronics EEE development processes and support the complete electrical architecture, harness the power electronic and software control, which are core to the development of electrification. Moreover, these complex products need sophisticated analysis, which means that when you are developing this product, you need to make sure the product is basically comply to the thermal performance, it complies to the noise vibration optimization, there is the EMI, EMC reduction, and basically able to do multi-attributes optimization between the various parameters in which the product need to be play around. The third key aspect of this fast-paced design development and optimization requires the e-powertrain development, which requires the battery technologies, motor, inverter across the electrical powertrain, which are key to the success of the vehicle electrification market. Now, these are the two trends. You need to make sure that you develop an e-powertrain, which is a battery, motor, inverters. Key chain is that electrical electronics are properly integrated. And when you are taking basically a balance of these two areas, the vehicle engineering, which is the performance of the vehicle, the inside cabin experience of the end consumer is very much important on top of that. So basically, really, these are the solutions which can really allow the customer to do the innovation faster. And on top of that, Siemens also provides solution where the complete manufacturing process engineering, the virtual design of a new lines, and basically how the new technological products, because these are moving away from conventional manufacturing to basically introducing products which are lightweight, new kind of assemblies for motors and inverters that require a virtual simulation of the production, really help in bringing the products right to the market and bringing it to the market fast. Now, when we look into the intricacies of electric and electronic system, that demands basically a model-based system engineering framework approach in the engineering. Now, which basically that optimize electric system engineering, allow the electrical engineers to really leverage a generative approach for system design, which are based on the system inputs. That tool can really help them navigate the necessary design changes to make sure that whatever the basically new age components which are being part of the vehicle are validated and verified virtually. Now, this flexible and open ecosystem really accelerates the design and build inherent quality and safety for the product while meeting the cost and weight target. Now, vehicle engineering is the next step, which is basically as challenging as ever, especially for the electrified vehicle. And this is basically required to make sure that you maximize on the product range, then cabin comfort, and the overall system performance. Now, this involves engineering the new age vehicles with newer, lighter materials, with an eye on this new lighter materials can be manufacturable. The various components can be joined together. The strategies on how this basically new component will be assembled, how basically this component can be optimized for power consumption and still giving a cabin comfort to the consumer, and balancing the overall vehicle at a vehicle level various attributes in terms of aerodynamics, noise, vibration, thermal component. With this basically approach, they are able to basically, the automakers can really maximize the system performance of the vehicle and still can create a vehicle while meeting the cost target, the weight target, and the safety target which is required for these kind of components, these kind of products. One of the key aspects of once you have solved the kind of electrification need of the product, the kind of lightweighting of the product which is required, the third key element is the e-powertrain, which is really the DNA of the new age product, where it's very much important that energy storage and density, as well as the power consumption performance for the EV, remains one of the most challenging aspects. There are always these what we call the range anxiety, right? You are able to deliver to that particular one for which your product is selling it to the market. This is the product range it will deliver, and that need to be delivered consistently across the product which are going. So seamless, basically, a digital thread is required from Lion's cell chemistry evaluation to cell pack design to thermal management and the vehicle integration, which means that evaluating the various operating parameters of the vehicle. Now, in this addition to only to the battery, the engineers also need to optimize the motor and overall drivetrain performance for operational duty cycles, basically related noise, and the basically electromagnetic performance related issues which may come out of the particular vehicle. Another key challenge with basically the e-power development is in the area of power electronics, which really needs one of a kind of integrated design, simulation, and testing to make sure that the electronic components which are basically embedded within the product are reliable, they are durable, and they will basically meet the issues, meet the need of operability needs of the electrical powertrain. Now, so to summarize this particular 3 turn, once these 3 core elements of the product are being taken care, one of the most challenging issue will be how this electrical vehicle can be manufactured. Now, here the engineers need to bring in the simulation to really verify and validate the processes before really implementing them on the shop floor. So you do the virtual trial, you do the virtual manufacturing, really launch it on the production. That really will make sure that production is basically a cost-effective manufacturing. Now, auto manufacturing need to attain higher efficient project by leveraging the advancements which are available in digital technologies. They need to explore and validate the processes, the equipment by which they are going to assemble them, and really make sure that the production execution is seamless and product is launched to the market with the right, basically, cost target, cost overhead. Now, overall, the vehicle electrification, the Siemens solution can ensure the functional safety across the domain. The key challenges are addressed, whether it is an integrated electrical electronic system, whether it is in vehicle engineering, whether it is an e-powertrain development, or doing the virtual prove out before the production launch. Now, Siemens deliver this with accelerator solution as a service, which basically provide all the key 3 elements which we talked about of comprehensive digital twin, personalized, adaptable, modern, giving the right kind of digital capability to execute that, and very flexible and open system, which are basically flexible in deploying, flexible in basically integrating with existing IT assets on top of that. Siemens solution are central today to the industry, automotive industry electrification efforts. We have the experience both within the country and within the globally, both in terms of developing the batteries or both in developing the vehicles which are there. There are multiple use cases by which we have supported the customer. Tesla is one of the examples which was able to solve their production problem related to electrical configuration variability which is required, and the OEM supplier data exchange which needs for developing these kind of methods. Tesla was able to boost their production capability with Siemens solution. With that, I will basically summarize my session that accelerate your electrification to basically really meet the customer demand and the zero emission, and to maximize the range of your product. With this, I would like to thank for spending time with me, and thanks again to ET Auto for hosting me in this session. Really, thank you everyone. Have a great day and great session.
Thank you, Mr. Bansotra, for sharing your thoughts with us. Now let's move to the next session. Stay tuned, everyone.